everybody, I'm back, and believe it or not, I am inside the bonus quiz for 4.2, where it's absolutely mandatory I talk about the two main ideas here before I tackle those two problems on the bonus quiz. The two main ideas being union and intersection. And I think the words themselves point at their definitions. That it's almost as if the sounds of the words uh, give you the definitions of the words as well. Union for me is an encompassing, inclusive word. It means marriage, and that's precisely the mathematical definition. It says it doesn't matter uh, where you come from or who you are. We're going to include everybody in the final solution. We're not going to discriminate. Everybody who solves either this one or this one uh, is included and welcome to the party. So union is encompassing. And the word in logic for union is or, and it's a nice round inclusive word. And the math symbol for union is the U, and of course, union for you, but also a smooth letter. It all works together for me, and I take everything I can leverage to learn these ideas, and so the sounds themselves now intersection. That's a sharper, more penetrating, more discriminating kind of word, and in fact, that's the idea behind this idea in math. Uh, we don't want solutions um, just from one inequality or from the other inequality. We're going to discriminate, and you have to simultaneously work in both inequalities or both solution sets. So for example, suppose this is a visual of all the solutions to x is greater than 0. All numbers greater than 0 are right there. And suppose this is the uh, visual set for all numbers less than 3. And the question is there an overlap? Can we discriminate and just talk about those that solve these simultaneously? And there is. Numbers like 1 are greater than 0 and less than 3. And 2 as well, and all numbers in between. There's an infinite number of numbers that satisfy both of these inequalities simultaneously. And notice the word and itself is a sharp, discriminating kind of word. It's got that point to it, and the math symbol for intersection is also more penetrating, sharper than that for union. So I leverage all these ideas to get home and safely navigate the math. So go with what's built into your brain. And union and intersection, the sounds themselves. Now, here is intersection. And so we're looking to discriminate. And we only want those elements that are common to both sets. And there's only one. M is here and M is here. So this is not the empty set. They do have something in common. And the question is, what is it? It's the single element M. So that is the answer to this first one. And let's get on to the second one. Now at this point in time, we start to enter a more difficult passages in our textbook. This second half of 4.2 and most of 4.3 involve these compound inequalities, as they're called. And this is more difficult stuff. Now, not only is this a compound inequality, but it's written in an abbreviated form. And I want you to take this advice to heart. Don't go making these abbreviations on your own. If you're given a problem like we are here that's already in abbreviated form, that's fine. But avoid trouble. Don't make them on your own. If you can swing around that trouble spot, do so. And so, see, for me, this compound inequality is going to involve an and that's just because as a math teacher I have to know that. And but for you, I don't think you really have to bother yourself. Is this an and or an or condition? I think you just solve it and you'll see that and gets forced out of the situation. So here it is, and we're going to solve it. We're going to subtract, to isolate x, we're going to subtract 1 from all three sides. And when we do that, over here we get negative 6 minus 1, which is negative 7. And then we've done what we wanted to do. We've isolated x. And over here we have 7 minus 1, which is 6. Now you see, what we have here is a situation that lends itself to the word and. We have two inequalities. There's this one, x is less than 6, and there's this one, x is greater than or equal to negative 7. And what this is saying, and it's the reason why and intersection fall out of it, it's saying that simultaneously x has to be less than 6 and greater than or equal to negative 7. Simultaneously. And so that's an and situation. That's an intersection situation. And if I write my answer here in terms of interval notation, it's going to be all numbers, including negative 7, to the right, going towards 6, but not including 6. And so in interval notation, it looks like that. The numbers that simultaneously satisfy are represented by this interval notation. And so let's see what they're asking us here. They want us to use set builder notation, and so that will be this. And then they want us to choose the graph of the solution. And the nice thing about going to interval notation is I can then pretty much go over and look for square bracket negative 7. So I'm going to come over here and look for square bracket negative 7, and that's this, all the way over to the right to 7, or to 6, but excluding 6. So the answer here is going to be B, and this. So let's go ahead and get this out of the way. And so we have negative 7, and then lesser than or equal to x, and then lesser than 6. And so we also said it was this one. And so that's it. Compound inequalities, once again, I warn you, if they come at you in abbreviated form, you definitely want to solve it that way, but don't make those abbreviations on your own. You'll avoid a lot of trouble. 2 green arrows. Okay, so we're good to go. I hope that helps.